Okay, we're good. That lab yesterday was hard.
It's like it gave you 2 easy questions and then
Nothing was easy again.
yeah, it was just weird.
I met with our teacher during like his office hours when they was like calculating the coefficient. So I was like, I
Yeah.
have no idea. Like I would look it up online and it was totally different. And nothing in the book really gave an equation. And then he just like whipped out an equation out of nowhere and he's like, don't you understand? And I was like, no.
That's so weird. I had to go ask my dad for help because he used to be a chemistry and physics teacher.
Hmm.
And so uh, he went and found this book.
Yeah.
So he brought that back and I don't know why he did this, but he subscribed to something and he's been finding all the questions on that thing because everyone asks about it.
I'm so
And he's like, watch it step by step. And it's like, they don't give us these equations.
yeah, so half of them, yeah, when I find answers online that like explain how to do the problem, it's like I don't have any of these equations. How am I supposed to do this?
It's
There's
crazy.
like number 11. So I found like the area in the forest and then it's like I don't know how to figure out how much it compresses. And I found an equation online which is like E equals WG divided by E, but I don't know what E is. So
I found from that same place we found one that was what was it? It was like the triangle L equals 1 over the Latin Y divided by force by area is initial length. It works, but it was like
if it works, it works. I don't know how we're supposed to find it, but it works. Okay,
no.
let's start. So
Alrighty.
I have the only one I don't have complete is the last part of 11, and then the rock climber one I have B, but I don't have B.
Okay. So I have everything done this time. 7 is the one I felt iffy on. The one with the tractor and the airplane.
I think I've got that one. We'll see if I've got that one. Okay.
Okay.
So for
But
one, I put when a car is on cruise control on a flat, straight road, then you'll have non-zero velocity while the external force is zero. What is your example?
um so the net force is 0,
Mhm.
then the velocity is constant because it's a non-zero velocity, like you're floating out in space in a direction.
Oh, that's smarter than a car. Just okay. I'll write
It
that.
was hard to find an example on that one because
I
it's
know because it's like these aren't situations that like they happen, but not like commonly.
I know.
Okay.
Like who's going to be randomly floating out in space?
Yeah, exactly.
Okay.
So in two, to get A, so calculate her mass, I divided the force 50 divided by the acceleration was the 0.893, which gave me 55.991. So she weighs, or she has a mass of 56 kilograms.
That's what I got.
Okay? And then, where is it? For B, I had, unless you consider the vehicle's acceleration, you'll overestimate the amount of acceleration because your observed acceleration is the astronaut plus the vehicle's acceleration. So if you don't consider the vehicle, you'll say she's going faster than she actually is.
Which is true.
Yeah.
On that subscription my dad sent me, they gave any.
You're going to have to send this over because I might need to invest.
It's I'll
It's
let you know what it is, but I know it's like Chegg.
okay. Have you done the individual exercises at all yet?
No, I'm going to be doing that today.
Okay, so they're all like draw the free body. Well, the first one. I got stuck on the first one and then I gave up, so I haven't done any more.
How many are there?
I think there's 9 questions.
Okay.
And the first one is like draw the free body diagram. I did the one that's like the more complicated. So part B, I did it and I got a 100. Part A is supposed to be simple, and I don't know what I'm doing wrong on it. Yeah, so that's fun for me. Okay. What did you say a way to avoid recoil is?
So, the way to do it separately is, so if the force of the astronaut is recorded separately from the vehicle, then the recoil on the vehicle can be avoided. So,
okay, that makes more sense than what I wrote.
yeah. Well, yours made sense too. The way they described it is you have the two forces, but you do need the, what is it? If the force the astronaut experiences is equal to the force the vehicle experiences, then you have MS/AS equals MA/AA for the ship and astronaut. Therefore, the acceleration of the astronaut to the ship can be found by AA equals MS/AS over MA.
Yeah. The other thing I said is like have the force come from something other than that vehicle. That way you wouldn't get the like kickback because it experiences the equal but opposite force. I don't know how you would do that. But
It's a really weird one to explain, even with the definition I found.
I don't know. Yeah, it's weird.
Yeah.
So for 3, what were we solving? Okay, we were solving what force does the motorcycle exert backwards on the ground to produce its acceleration if the mass is 245. So to get force, I did 245 multiplied by the acceleration, which is 3.5, and I got 857.5 newtons. And then I added the original 400 newtons, which gave me 1,258 total newtons.
That's what I got. I did the 1257.5. But it does look like it doesn't want that decimal for that.
I'm wondering if we need to put it in scientific notation so they're all only 3 significant figures.
Well, if it's a whole number like that, I know it's fine.
Okay.
Though once you get down to 11,
Mm-hmm.
so 11 was probably the weirdest one I've seen out of all these as far as it's set up, because it does use scientific notation in the answer on that website.
Oh.
So
you'll have to help me with that when we get there. Okay, so for 4, we're trying to explain how the football player can outpush the opposition if he is strong enough. I said as long as he has more mass, he can outpush the opposing player, because the third law says equal and opposite forces interact between 2 objects but still act on different objects. So as long as he has the bigger mass, he'll be able to displace the person with the smaller mass.
I said if he adds more force, I assumed they were the same mass, is what I did.
Okay. Well, I think force is mass times acceleration, right? So if he weighs more or if he goes faster, he should be able to outpush him, right?
Right. I like yours better then, because my so I drew the free body diagram.
Okay. I hate these. So what did you draw? Because I don't think I drew anything right.
So according to the website I've been using, they make it like a graphing type.
So I have
design.
F normal going up and F gravity going down for both of them. And then I have, on one of them, I have the friction for player 1 going this way, and then the other one I have it going the opposite way. And then player 2 going this way and player 2 going this way. But I don't know if that's right.
How mine is so you have player 2 in the middle of the graph, like at the origin.
So you made him the like,
particle that you're trying to move.
yeah.
And so you have force going one way, friction going the other way.
Yeah.
You're also pushing up, and then gravity and mass is pushing down.
Okay, circle that. We're gonna send your photo of that in because
Okay. I better fix up this definition though, because you're right about mass and acceleration.
do you want me to tell you what I said again?
Yes, please.
Okay, so I have third law says equal and opposite forces interact between two objects, but still act on different objects. So as long as he has more mass or accelerates faster, he can outpush the opposing player. And then in like parentheses, put like force equals mass times acceleration. Wrap that all up.
One has more mass. Eight. Two. The opposite direction. F equals N A. There we go.
Okay.
That it should work.
Yeah. No,
It's strange when trying to word things because, like, as you read some of these questions, it's like, oh, it's going backward. When really they mean it's going this way, not that way.
yeah. Yeah,
It's
it
like,
does. Yeah, it's hard. The words I feel like are what trip me up. So as soon as it's a lot of words, I'm like, "Whoop, I'm gone. Okay.
yeah.
For number 5, for A, we're trying to find the friction between the losing player's feet in the grass.
Mm-hmm.
So I have F total equals the F minus the friction, so the force minus the force of friction.
Yes.
So I have, I set it up so we have the total force, which is 90 times 1.2 equals 800 newtons minus force of friction. So then I solved, like I did 800 minus the 108 from the 90 multiplied by 1.2. And that gave me 692 newtons.
That's what I got.
Okay. And then for B, I got 90 plus 110 multiplied by 1.2. Oh, wait, we're solving for the winning player. So
Right.
90 plus 110, multiply that by 1.2, and that equals the force minus 692. So then I added the 240 to 692, and I got 932 newtons.
I got 1,078 newtons.
How'd you solve for that one?
What force does the winning player exert on the ground to move forward if his mass plus equipment is 110 kilograms? So force to the ground, so you have gravity this time. He's not moving forward, it's just asking about the force on the ground.
Yeah.
So it'd be 110 times 9.8 to find the force on the ground that
Okay.
has to exert in order to move.
That makes sense to me. And do you have the free body diagrams on there?
I do.
Okay, we can use your number 5 then as well. Because I hate those diagrams.
Each one's different too.
I know. Like they're not, there's no right, like they're random, which is what I don't like. Okay. For 6, A is what is the tension in the rope if he climbs at a constant speed? So the equation for tension, not tension. So tension equals mass times acceleration plus, wait, where am I getting this from? Give me a second, I've got to think.
So the force
You do this.
so force equals tension minus the force of gravity and mass.
Oh, is that where I got that from?
So FMA equals tension equals.
Okay. I couldn't figure out where I
energy.
got the 588 from. It makes sense now.
Yeah. I was actually trying to find this equation later, and I forgot it was on this page.
Okay.
It would have helped.
And it's the 60 multiplied by 0, so that cancels it out. So it's just 588, right?
588. Yep.
And then for the next one, I have 60 multiplied by 1.5 plus 588, and I got 678.
Yep. That's what I got.
Oh, I have my equation for W right here. I don't know how I
W.
missed that. Okay. That was good. Okay. 4, 7. A is.
Okay, this is the one I had trouble on because I didn't quite understand what to use.
So in A, it's if the acceleration is 0.15, what is the mass of the airplane? So to get the total, so I got the total, I calculated the total friction, so then I could plug it into F equals MA. So I did the 17,500, which is the like 1.75 times 10 to the 4 newtons. And then I subtracted the 240 newtons because it's resisting the motion. And that gave me 15,100 newtons. And then I have mass equals the 15,100 divided by the acceleration, which is 0.150. And I got mass equals 1.01 times 10 to the 5th kilograms.
Decent sized plane.
Yeah, it's like 100,000 pounds, 100,600 pounds. Yeah. And then B, I did the force equals MA plus the friction of resistance.
So plus 2,400.
Yeah, so I did that giant mass of the plane multiplied by the 0.150 plus 2,400 or 2,200. Yeah, and then I got 17,300 newtons.
Okay.
Which makes sense.
So did you add or subtract the 2,200?
I added.
Okay. Okay. That makes sense. That makes a lot more sense than what I was trying to do.
Okay. What did you do for your free body diagram?
So for the free body diagram, so this one I thought was a little tricky because you have the force of the tractor moving forward. So you have the tractor in the plane being pretty much one unit.
Okay.
And so you have the 1.75 times 10 to the 4th moving forward. And then you have the friction of the 2,400 newtons and 2,200 newtons moving the other way.
Okay. So if I put it as the force, normal force going up and gravity going down, and then to the right I have the force of the train plus plane, and then to the left I have the force of resistance.
Right.
Is that what you have?
So yeah, I have the general force of the tractor. You have the better numbers than I do.
Yeah.
So it makes much more sense. But I have the force of the tractor pushing on the plane going to the right.
So the one from B, so the 17,000 plus is going to the right.
Right. That is correct.
And then the going to the left would be the 2,400, which is the resisting motion.
Right.
And then you just have the normal gravity and normal force.
Right.
Okay, then we can use my picture for this one. 8, I'm not positive I did right. So for A, I just did 12,000 sine of 2, which gave me 418.79. Is that what you got?
So I figured the y and x of it, and
Mhm.
I did the Pythagorean theorem to see, like, so I have all these numbers, but the
But
sine one that you just said
the
is
Pythagorean
418.
theorem, because I don't think
Well,
it's a right triangle. Can you use it?
you can only use Pythagorean theorem as long as you're trying to find the hypotenuse.
Oh, okay. I didn't know that.
Yeah. Um,
Okay,
Sine and cosine work well when it's a right triangle, but you can also use it when it's not.
because I use sine, which is how. Sorry, my dog is in my room and she's like staring at the ceiling. I don't know what for. Um,
It's all good.
so what did you get for A?
Okay. Perpendicular to the center of the rope. So it would have been what you just said, because I went ahead and found the hypotenuse if there was a triangle,
Yeah.
and that almost puts it back at 12,000 newtons.
Oh, okay.
That makes
So,
sense?
yeah. So for A, I got 418.79, which I think I should just make 419.
That's what I got.
Okay. And I'll circle that. And then for B, I don't know if I did it right, but it was just asking how would it change if you did 7 degrees, right?
Right.
I did the exact same thing, but I put 7 degrees instead of 2 degrees.
Did you come out with about 1,462.43?
I got that exact thing.
Right.
I'm just gonna make it 1462 though.
That's probably wise. It looks like they rounded it, because when I did the Pythagorean theorem
Uh-huh.
for both of them, so the first one came out 11,999.99,
Yeah.
and the second one came out 11,999.99 as well.
Yeah.
So that's probably the answers they're looking for those. So we can use yours.
Okay. So wait, which ones of mine are we using? Because I'm gonna put a star on them so I don't forget. So we can use my page for 7 and 8. Because
Okay, that works perfectly. Um,
then did we both have the same thing for 5 and 6? I think we did. Or
I,
I think you had the better free body diagram, correct?
for four had the
I
free
think,
body diagram as well as 5.
okay. So then are yours all on one page? Are your 5 and 6 on one page?
3 and 4 are one page, 5 and 6 are one page.
Okay, so you can send photos of 5 and 6 and 3 and 4. Does that sound good to you?
Yeah.
And then I can do 1 and 2, and then 7 and 8, and then we'll figure out the last 2 pages. Okay,
Okay.
back on track. So 9 is the one where I have no idea what to do for A. Like,
Okay. This was crazy because I went back to that subscribed website,
yeah.
and they literally have every single one of these questions.
Oh, dang.
I only looked up the ones that I had trouble with
Yeah.
for the most part. 7, I tried, and for some reason I just couldn't get it and forgot to look that one up. But so for 9,
Yeah.
this mess
Oh, jeez.
of equations
So it's not a
that
simple.
you have to know trig and have memorized trig.
It's been so long. It's been like 2 months.
I know. I wasn't wanting to pull up my binder that still has all those notes. I was like,
I honestly
no.
don't know my this. Okay, so how did you solve for A?
Okay. I'll try to go step by step, but I'll cut out some of it because there is a lot. So for A, we know that the force of X is 0. So
Okay.
we're trying to find the tensile of the rope and the force that the mountain climber's feet need to be on the rock face to remain stationary and assume that the force is exerted parallel to her legs. So x is 0.
Okay. I can follow.
Okay. Now this is where it gets tricky because now we start using cosine and sine with force and tensile.
Okay.
So you have the force cosine 15 equals tensile sine 31, and that all equals 0.
Okay.
And so with that, F equals tension sine 31 over cosine 15. So now you can actually take out the t because you plug that in to where the F cosine 15 is. So everything can be t.
Okay.
And then you're also supposed to find the force of the mountain climber with gravity, because without that you won't get the tensile.
Yeah, and that'll be the 52 kilograms multiplied by 9.8, correct?
Right. So all of the tensile, cosine, and sine stuff needs to equal the 509.6.
Okay.
And then when you plug it in, you pretty much take out the t, distribute the sines and cosines, so you can start getting t by itself.
Okay.
And then eventually you get to t equals 509.6 cosine 15 over cosine 31 times cosine 15 plus sine 31 plus sine 15.
Okay.
That's the ending equation, and then you get a tension strength of 512 newtons.
I believe you. That sounds right to me. Sure.
I skipped about 2 things in there.
So I know
There's-
you're submitting number 9.
Okay.
B, I just did. I don't even know if I did it right. I just did tangent of 15 degrees, but I don't think that's right because it gave
That
me
is right.
that is, and I got 0.2679.
0.269. I got what they had on the website is 0.268.
Yeah, that's just mine rounded.
Yeah.
Okay, that makes
I don't think it really matters at that point, but
Yeah.
but yeah, you are right. They went through the whole process again, but it's not as long as A, so I was glad for that.
Okay, for 10, I just said that gas can be compressed. So when you allow there to be gas in your bottle, it allows for the liquid to expand without bursting, like having so much pressure it causes the glass to burst. That's all I said.
That's a short answer than what I gave.
What did you say?
So the volume of the vinegar, if completely filled, if it completely filled the bottle with no air, would break the bottle when expanded because the increased volume of the vinegar has increased more than the volume of the bottle. Therefore, with a pocket of air, air is more compressible, and with enough compressible air, the bottle will not break when the vinegar expands.
Yeah, that's good. So do you want to take a picture of 9 and 10?
Yeah,
Okay.
I can do that.
And then for 11. So I started it out by calculating the area and the force. So to get the area of the cylinder, so area for a circle is A equals pi r squared.
Mm-hmm.
So I did pi multiplied by 0.150 squared, which gave me 0.0769 meters squared.
What was the answer that you got?
0.0769 meters squared is the area. And then for force, I did the mass, so 400 plus the 72 from the physicist. And I multiplied that by gravity. So I got 4,630 newtons. And that's as far as I got.
Okay.
Because I found the equation for compression is E equals WG divided by E, but I just didn't know what E was. So I think the WG will be like the 4,630 multiplied by the 610, but I don't know what the E is, so I can't go any farther than that.
Okay. So what I got for area, and I think I'm hearing you right, but for some reason I don't know. I might not be hearing something. So area 0.0706 is what I got.
That's not what I got, but it's kind of close. Let me make sure I did my calculation right.
Square the R times by pi. If you have a pi symbol, that's what I used.
Oh, wait. Yeah, I have a pi symbol. Just give me a second to make sure. Oh, what you have is right. I don't know how I got.
And what was the force of newtons with the equipment and the guy that you got?
4,630. So I did 400 plus 72, and then I multiplied by 9.8, which is, oh, I rounded it.
Okay, that makes sense because I got 4,000.
4,626.
Okay. Yeah, I got 4,625.6.
Yeah, that's what I have. I'm just going to round it to 4,625 or 4,626.
So this one isn't as lengthy as 9, but it does have a funky equation.
Oh, okay.
And I will have to get you the name of this website because they take it step by step, so it isn't like
So you can follow along.
which is nice. Even though there's something I'm like, where do you get this? But
yeah,
it's easier to understand than the videos and the book. So
okay.
This is what I have, and it's the triangle little l equals 1 over, it's like a y, it's a Latin y.
Yeah.
So 1 over the Latin y times F over area. So force over area times initial length, or in this case, height.
Yeah. So the 610.
Right. So I don't know where they got these numbers because the Latin y significant means a certain number.
Okay. It's a constant.
So yes, so that number is 210.109.
Okay, I saw that somewhere else. The equation I looked up, that was the little e. I just couldn't figure out where they got it from, so I just stopped there.
It's all good. I would have stopped too. It's like, what is this? And then force divided by area times the 610.
Okay.
And what I got and what they got is 1.90 times 10 to the negative 4 meters.
What was it?
1.9, so 1.90
Okay.
times 10 to the negative 4.
Okay.
And it's meters. So that's how much.
So it barely compressed at all.
It barely compressed at all, yeah.
Okay. I feel like they would be like, see how much it compressed, and you'd be like, wow, that's so much. But that was like, you wouldn't even know.
It's hardly a fraction.
I know. I'm like, if I have to use significant values, a negative significant value it doesn't count. I mean,
What I like to do is, so one of my friends, he showed me this game theorist who was a rocket scientist.
oh my gosh. Okay.
Yeah, and the only time he's ever really used physics or calculus that he's learned in school is trying to figure out the math and physics of these games through
Oh,
it. But he actually uses formulas from physics and whatnot, and he shows what he's done.
that's kind
So
of
if you want a fun way to learn physics,
yeah. I mean, I'm kind of desperate at this point because I wouldn't describe my experience as fun.
I don't blame you. It's not fun.
Okay. Do you want me to send you the photos of my pages, or do you want to send your photos to me and I can submit them? Because I can send you the link to the video as well, and you just have to make it a PDF, and you have to put our names, the link, and then our pictures. So what do you want to do?
I can send it this time.
Okay.
So yeah, send it over. And you said make it into a PDF?
Yeah. And then put our names on it. And then I'm sending you problems 1 and 2. That's half of what you're sending. And 7 and 8, correct?
Correct.
Okay. I'll send those to you, and I'll include the link to the video in the email.
Okay.
Okay. Perfect. Let me get the link before I hang. Oh, wait. No. I'll get the link later. Okay. Thank you for being with me a day late. I really appreciate it.
It's all good. I'll work with you, okay?
Perfect. Thank you. See you next week.
See you next week. Take care.
Bye.